Hi, hi team. This is Brenda. Here the agenda of the meeting today for today's agenda it's to discuss about that series, how we have started and core concepts of we are going to discuss about the core concepts of series, and we are going to talk about the current state of the series, and we are going to talk about what future changes we are going to have, and more in depth of architecture and designs that we are going to discuss today. This is the agenda of this meeting. Okay, let me first talk about, okay, I believe that most of the people know that architecture, okay, just for refreshment perspective, I am just going to explain or go through this PPT once again very fast. Okay, so this is a controller design studio architecture. So in this architecture, we are going to have major three components, I could say that. One is a blueprint processing platform. Okay, where real blueprint will be executed. Okay, so that we call a blueprint processing platform. It's like a separate microservice, separate container solution. Okay, I don't say that it's a microservice; it's a container, separate container. And we have a blueprint designer microservice, which will act like a management, designing what all the designing capabilities. Controller.
Can go on mute.
Controller blueprint microservice. Here, this is the core component. Okay, and other than that, we have finally we have a controller design UI. Okay, mostly it's a Angular based applications that we are going to have. Okay, that's a high level architecture that we have, and mostly we want to concentrate a lot on the blueprint processing platform because that's a core platform which executes that blueprint. Okay. So let me talk a little bit about that. What are the core components here? So we have that. This is a completely Spring Boot application. So what we have chosen Spring Boot application. It's a separate container solution. We want to have that. We don't want to have this kind of solution inside that ODL, which is not relevant to ODL. Okay, which is not a controller aspects of controller functionality. That's the reason we want to separate it out, and then we want to scale it out. That's the reason we have separated the core functionality or blueprint processing platform outside of this ODL. Okay, so we have a REST services. Okay, REST or gRPC or API services. Okay, right now we have a REST and gRPC exposed endpoint in a blueprint processing platform, and we have a tiny directed graph. Okay, this is not that actual directed graph which we used inside the ODL. Here we are doing a component or function orchestration. Okay, we are not doing low level orchestration. I could say that it's like only the component orchestration. Okay, in order to avoid a lot of complexity and keeping in the mind of self-service perspective. So we are using the directed graph. And once we mature and we can use our DSL language and own inbuilt workflow engine to do that. Okay, just for time being, so we are using a directed graph because it's a lightweight and it suits for our case for right now. Yeah, that's the reason we are using a directed graph just for component orchestration, not more than that. Okay, and we have a capability components or called functions. We could say that the functions. Okay, these are all dynamic. And it is with respect to that organization. Okay, mostly we are trying to build in ONA the reusable functions or reusable capability components, but there may be so many situations, lot of situations you may inside that organization you may want to create your own capability component and inject those components and try to orchestrate that. Okay, so we are trying to build an architecture so where you can inject your own custom components and as well as make use of in your self-service perspective. And we have certain reusable libraries. Okay, so REST adapters, it's a configuration-based REST adapters, and then configuration-based DB adapter, and some other team is working on that configuration-based DMAP publisher. Okay, DMAP publisher I could say, and DMAP consumer. Okay, for Dublin release we are concentrating on the DMAP publisher or producer. Okay, and REST adapters and DB adapters, and we have our device components. Okay, device capability components such as a netconf or RESTconf, so we can make use of that. And we can also have our own capability components. In our case, our own capability components, I could say that, okay, resource resolution is one of our key capability components. Even you can include your own capability components, such as if whatever the business logic you want to have that. Okay, so you can build your own capability component. This is the entire architecture of a blueprint processing platform. It's very simple. It's a Spring Boot application which exposes both endpoints, gRPC and REST endpoints. Okay, and most probably we are going to prefer that gRPC in future. Okay, just for time being, we are just exposing in order to support for legacy platform. We are asking that REST endpoint. And moreover, if you want to make use of this platform to consume or to provide any services, you can expose your own REST endpoint, and you can also inject. And moreover, our ultimate aim is to provide a platform capability, not like each individual case or each individual use case of the particular VNF or particular service-based use cases. Okay, this is a reusable platform. Either you can use it as an individual standalone system or standalone application itself, or else you can use it for specific service itself. Okay, it is up to you how you want to use that. Okay, any use cases you can try to build along with that. Okay, sometimes you want to build for separate firewall use case as a separate service or as a separate processing platform. You can also make use of that. Okay, you can create it is up to your organization and how you want to build that. Okay, and along with that, we are trying to have the interface with other application, other components, key components inside the OneUp, such as ANI, policy, and even networks also. Okay, you can build your own adapters and then make use of that. Okay, this is overall architecture. And I have given that technologies. Okay, so even this blueprint processor exposes gRPC 8, which can be invoked from current existing flow, current directed graph flow itself. You can make use of this platform itself. So in that case, you don't want to think like we are trying to build a separate platform which can't be integrated. So in that case, you can already Alexi built a gRPC client on the ODL side. So similarly, you can build that client or you can make use of that existing client itself and try to connect with the CDS platform. So that's all about. And we have a embedded Tomcat or embedded NetT. Based on that, how if you are trying to expose the two things, based on that it will change. And for certain database, we are using a MariaDB for even for temporary design caching perspective. Also, we are trying to use, and as well as the Blueprint runtime platform itself. In order to store the transaction information, in order to store that some primary database information or primary data source information. If you want to store that, we can make use of MariaDB. It is up to you. You can use the same DB and you can share that across the microservices, or you can have own DB instance. It is up to you. It is up to you. Okay. And finally, we are using a Spring Boot Web Flux framework. Okay, it is not a legacy MVC framework. Okay, it is a non-blocking Spring Web Flux framework. And other technologies we are using for directed graph. Okay, we are using Java. We are using some places, and Kotlin we are using, and Python we are using. I could say that is according to scripting technology, we are using a Python and Kotlin scripts. Okay, I will deep dive later. And from modeling perspective, okay, we are using a JSON model for a blueprint. Okay, and here we use the Tasca definition. Okay, in a JSON format. So that's a blueprint we call controller blueprint. And from ODL perspective, we are using a Yang, and then we are having a Swagger. Okay, just to expose or just to share the definition based on the blueprint. So we are using a Swagger, and then for templating, we are using a Velocity. Later it can enhance to that any kind of templates. Okay, it's a matter of building your capability components, how we want to process the templates. Okay, and adapter perspective. Okay, we have netconf and then restconf planning to do that, but not for Dublin, and then Ansible planning to do that, not for Dublin. Yeah, we have netconf. Our plan for Dublin is mostly netconf. We are concentrating on the netconf, and rest of the things we will, based on our workloads, we can try to look into that. Yeah. Any points that I want to pitch in more deep with respect to that high level architecture?
Yes, I have a few questions actually. There's something also in the implementation. We refer to this, as a resource resolution, right? Like for basically resolving the different values required by service template, right? So where that would fit in this, would that be in the capability components, or
Yeah, exactly.
is it
That is a
something else?
capability component.
Okay, that's first. Second, here we see three databases, right? We see the CDS database, the CB database, the BP database. Could you shed some light about, which is which, and, because in the implementation, there's two main microservices, right? There's the processing and there's the design, right? Like there's the execution and the design side, right? But here I see actually three databases. So could you just shed some light a little bit about, which is which, and what are the purposes of those databases, please?
So, this is a UI database. I think most probably not aware of that. Arundhati and Elil working on this UI. It's a completely UI driven, okay? So, which is Angular based application that is called Controller Design Studio. That is with respect to, in order to keep track of how many users logged into that, what kind of events it has published to that user. In order to store that certain information, UI related information, that we have it in Controller Design Studio. It's nothing but UI related database we have. And this database is completely artifact management, designer perspective, okay? That is controller blueprint, okay, which keep tracks of a reusable data dictionary and reusable templates, okay? Mostly in a design aspects, okay, what all the data that we want to cache, and then mostly it is not a persistence one. Each and every time it creates from that whatever the instance that you are trying to create. Okay, this is a designer perspective database, and this is a processing related database. Say for an example, you are getting a request to your blueprint processing platform. It has to store that value, okay, request information, and as well as the transaction information, as well as the logging information, events information. Okay, all those things you can store it here. And as well as, for an example, later point of time, if you are, once you integrate with SDC, okay, SDC, then SDC, that blueprint will be published from SDC, and we want to store that controller blueprint artifacts, right? So that artifacts will be stored in a blueprint DB. Right? I think I have explained that. Is it clear, or you want more information?
Yeah, this is good. So, so in the controller blueprint MS, that the CB database, okay, that's not the SDC database, right? That's yet another thing, right?
Yeah, exactly.
Okay. Another question. There's also a concept of the data dictionaries. Where that would fit in this figure, the data dictionaries, would that be as well? No, that's not component. That's not capability component.
That sits under designer, okay, controller blueprint microservice.
Okay, because this is during the design time. Okay, perfect. Thank you.
Okay, let me move on to that next slide. Okay, just to talk about the data flow, high level, just to more deep. Okay, so what happens? It's like initially user creates a model, and assume that user creates a model and check-ins that model inside the Git, because we want to keep track of all the blueprints model in a version control. That's the reason we are using a Git as a version control for all the models, even data dictionaries and starter templates, okay, or initial templates. Okay, we are trying to use that. And from there we are trying to build as a Maven bundle, okay, Maven bundle project, and that bundle can be reusable, okay, during that microservice loading process, okay, during that loading or during that packing, okay, during creating that controller blueprint microservice platform itself, designer platform itself. You can select that what are the models that I'm going to, what are the reusable dictionaries that I'm going to use, what are the context templates that I'm going to use, all those things that you can design the controller blueprint microservice Docker image, and based on that, okay, you can pull that information and keeps that information along with that image, and during that instantiation of that particular microservice, it loads that information, loads that all the dictionary and the starter templates, okay, and some other templates, okay, inside its DB. So whenever this microservice starts, it creates a fresh, it overrides or recreates that entire information so that it will be specific to that instance what we need actually. So that's the purpose about that's all about this particular flow. Maybe you guys know, that's the reason I am going fast, okay, and stop me if you need more information, okay. And So assume that you have a started of templates and data dictionary for the with respect to the for certain services. It's already there. I think somebody raised that question. Anything? Raj, you want to discuss? Oh, sorry. Sorry, guys. I don't know what to. Are you able to see my screen?
Not anymore. Are you hearing us? Hearing us?
Now I could hear you. I could hear
Yeah,
you.
I think we were trying to ask questions, but we were kind of muted by the organizer. If you go back to the NetConf, the plan, you mentioned that we are not planning for RESTConf and Ansible, but NetConf is still for Dublin. Sorry, Brinda, we couldn't hear you.
It's for Dublin. We are planning for NetConf, and for next release, the next forthcoming releases, we are planning for RESTConf and Ansible. And if other team willing to participate in that developing the RESTConf, I think we are welcoming people to participate in the RESTConf also, or even for Dublin.
Okay, one question we had here is about exactly the difference between capabilities and device components, because I understood you saying that any component that talks to devices should be considered a device component. Is that correct? I understood you correct, sorry?
Exactly. Let me talk about little bit about that. Okay, a device component just only it exposes an API just to connect to the device. Okay, it does not involve in the transaction management, or it does not involve in the processing of the transaction. Okay, so what we are trying to do, we are trying to have that capability component layer. That layer along with the scripting management. So it's a dynamic scripting. It's a part of a self-service blueprint. Right. So based on that script, okay, it orchestrates that, or it low-level transaction management. It manages that low-level transaction using this device component, device utilities. I could say that device interfacing utilities. I could say. Is that clear?
So device utilities is equivalent to device component. It's the same thing.
Exactly, because no, it has a certain set of APIs. Okay, like edit config, get config. Okay, these are all reusable components, right? So during that any transactions, okay, you can make use of that. But there
are no transactions, right? So this is just like a single message type of thing, right? There's no transactions. There's no higher level like sequences or state machines or anything.
Exactly. Okay. If you want to create a connection, also you can pass that relevant information, and then you can make use of connection. And using those connections, you can send a different configuration. Okay, edit configuration you can do, get configuration you can do. It's a high level. Okay, high level APIs to interact with the device. Okay. So this capability component tomorrow it may be a chef adapters or chef recipes. Okay. So for NetConf we are building our own. And it may be like even interfacing. It's like which does not involve transaction. It's a high-level reusable component, okay, which does not involve in the transaction, which doesn't bother about what kind of information that you are trying to interact with the device.
Just so that you know, Brinda, we no longer see your screen actually.
Oh, okay. 1 second. You could see my screen?
Not yet.
Not yet.
Really?
We can start seeing it here.
Really? I'm sharing my screen. Okay. Share it again.
We see here.
It shows like you are sharing your screen. It shows.
I see very well here.
Yeah, we see you now.
Okay. If there is no question, then can I move on to the next one?
Please.
Okay. Go ahead. So this is a flow about just how we are going to manage the templates and what kind of versioning that we are going to do, and how this blueprint processing platform it is going to get those information. Because during that template creation or during the data dictionary creation, okay, with respect to service specific, you can create the context. You can create your dictionary, and only you can select that certain which is relevant for the particular service creation or particular modeling or particular designing blueprint. Okay, so you can create 100 reusable starter templates, and you can select out of 100, you can select only two to make use of that. So in that case, you can have your own designer instance altogether. Okay, and coming back to that, here with this controller design studio UI, okay, you are going to design the controller blueprint with respect to service or with respect to customer. You are going to design, and the backend will be microservice, the controller blueprint microservice, which is backed with a database. Once you have done the design, okay, there are two options available. Okay, during the test options, okay, you don't want to use a SDC directly. You can push it during the testing phase, right? So we don't want each and every time we don't want to go to that SDC and publish that model from that SDC because of the time constraint, because of the lot of interfacing issues we have. Okay, so directly from here itself, controller blueprint, controller design itself, you can push that artifact, whatever the artifact we call a CBA file. That CBA file you can push directly to the blueprint processing platform. So in that blueprint processing platform, we have self-service API, which is both REST as well as the gRPC API. We have that, and we are planning to build a gRPC connection between controller design studio UI to blueprint processing platform, and with that we are going to publish that artifact. Okay, that once it receives that artifact called as controller CBA file. Okay, that CBA file will be persisted in blueprint database, blueprint microservice or blueprint processing platform database. Okay, so the main purpose of the database.
I just have a quick question, because you see on this figure right now we see two databases, right? So do I assume that the SDC in this case that's the third database which is related to the controller design studio UI, or it's just not shown here, or it's integrated in the controller design studio? The third one, like if you go back to the previous slide, right?
One second, just I will correct it.
Oh, okay, great. Because there was, the problem is that initially I was interpreting, that this Git and this Maven as a database. Okay, and this process with Git and Maven here, right?
Yeah.
Okay, so
the Maven Central, right?
Yeah. No, I get that, right? So what the whole blueprint, that this whole CBA will be Git, stored in Git, and then distributed to Maven, or what?
Let me explain that. Yeah. Okay. So first thing is we want to. First we want to version control, right? So for version control, okay, for keep track of. For version control, we have that controller. We have a Git. Okay, so that is for completely purely version control. Okay, so it means like who modified the template and all those things we need to keep track of that. And moreover, certain templates may be a possibility for reusable templates for other or forthcoming models actually. So that's the reason.
Sorry to interrupt. I just okay. So now, you were talking about a template, right? So you're referring to like the templates, like heat templates or velocity template. Well, or are we talking about what is a template in this case? Is it like the like if you look at a CBA file, we have like a bunch of JSON files in the right and containing the workflows, the node definitions.
One second. If you don't mind, can I take this call?
Sorry.
Okay.
Yeah. Okay. Sure. Please go ahead.
Yuri, if you don't mind, can you pause that recording? Yeah. Sure, yeah. Yuri, you could see my screen, right?
Yes, we can see.
Let me explain that. What is the purpose behind that actually? Actually, the template should come from SDC, right? So the templates and all distributions, it should happen from SDC. But along with that, we need to keep track of who modified that versions of, or who modified that corresponding blueprint, and what all the changes happened on the blueprint. Okay, certain things we want to do that and keep track of that, and as well as we want certain times we want to auto migrate that blueprints also. Okay, so we need some place where that automatic management should happen, as well as to keep track of what all the changes and who modified those changes. Okay, we need along with the SDC. But if you look into the SDC and records everything, it is all about that entire package level versioning. Okay, it is not it won't talk about that individual inside the content inside that inside the particular versions. Okay, so we want to keep track of that versions, and as well as it should be managed in a Maven Central, so that it should have that capability to build my own instance of a controller blueprint designer. Okay, so that kind of requirements we have. Okay, so that's the reason we need to have first keep track of what are the changes using a Git repository, and it has to be passed to that corresponding designer environment automatically. So that's the reason we have this flow. And this flow, blueprint processing platform, even though you can design any blueprint, but if it has to execute, then it has to be part of a blueprint processing platform. Okay, so for that we need to record or keep track of that blueprint processor, blueprint data information. So what we are going to execute. So that is all about. So we don't have a connectivity between designer to blueprint processing platform. Why? Because this artifact, what are all the blueprints that we are trying to create, it has to distribute from SDC, and for testing perspective, it has to distribute from the design studio itself. Okay, so that it should not go and access the designer. It should be distributed and it should be certified. Okay, so once it is certified, and then that certified information will be distributed to the blueprint processing platform. Okay, so further, in order to hold that certified blueprints, then we are using this database to keep track of that, right? Did I answer your question?
Yeah, it's okay.
Okay. So assume that for testing perspective, we are bypassing that SDC. Okay, just for test perspective, we don't want to go each and every time to SDC. So that's a controller design studio. From controller design studio itself, you can publish that artifact directly to a blueprint processing platform, and and once it receives, the blueprint processing platform receives that, it stores that CBA file directly into the database, right? And in real scenario, okay, in production scenario, what will happen? This controller design studio takes that CBA on the finally prepared that CBA file, and it pushes that CBA file to that SDC, and it will be part of a Caesar file, and that Caesar file will be distributed using a DMAP. Okay, and we have already UEB listener or DMAP listener. Okay, not only for CBA, it has a generic listener. We have that. So that adapter will listen for the particular Caesar file, and it extracts that component and places that same CBA file inside the corresponding database. Okay, so this is yet to implement. Okay, this is SDC integration yet to implement. Right now, we are concentrating on only the blueprint processing delivery from controller design studio. And once we have the SDC integration, this channel, the third point or third flow will work, right? Okay. Finally, assume that now you have a blueprint already stored, okay, which is nothing but a certified and published blueprint. It's stored in a processing platform DB. What will happen? You can simulate that request, or you can send that actual request. Okay, so even you can send that request from controller design studio, or you can send the request from SO. For a Dublin release, we are planning to have that integration from Controller Design Studio. From Controller Design Studio, you are going to invoke that corresponding request, okay, corresponding blueprint processing request. And once you send that request, okay, then it receives that request, and finally it looks for that blueprint processor, blueprint data, okay, that CBA file, extracts the CBA file and place it in a corresponding location. And I think you all know about that, what all the CBA content. Okay, let me go back and first show about what all the CBA content. Okay, the CBA content, it has a blueprint definition, okay, controller blueprint definitions, which is nothing but JSON file, and other definition, other type files, okay, which may be a node type, artifact type, and then relation requirement type, and as well as a dictionary. Okay, what all the dictionaries needed for this particular CBA, for this particular blueprints. Okay, all those things. Let me show that example. Okay, later. So that is a definition file we have, and a configuration file. This is a requirement specifically for one of the vendor. Actually, right now you can. Right now it is not implemented, so we already have this kind of assumption, like all the configuration files, such as a dynamic REST information, okay, other data source information, or dynamic configuration information. So all those things, it will be present here. It may be your custom application property. It's more of infrastructure related configuration information. Okay, we have that configuration, and then we have a plan. Okay, plan is a directed graph right now, and then later once we build that a DSL kind of workflow, and then we will have that DSL workflow. So these are plans or nothing but directed graph, and it's nothing but a simple orchestrator. Okay, so plan, and we have a scripts. Okay, scripts are dynamic scripts. Okay, which may be used in resource resolution process, because sometimes what happens, what all the capability that we are building, okay, it involves a development cycle. Okay, certain cases during the self-service perspective, thinking in a self-service perspective, we sometimes don't want to bring down the server, and we don't want to have a development cycle there. So we want to inject some piece of business logic, and we want to do a transaction management. So all those things that we can do with the help of scripts. Mostly we prefer a Kotlin, and because we have some security violations with respect to Python, and then we are trying to come up with a Kotlin-based kind of a scripting mechanism. And one more, it provides fast also. Kotlin script is more fast with respect to Python. So that's the reason we are planning for Kotlin and Python. Okay, we are going to support both. It's up to you. Okay, what kind of scripting language you can choose. Okay, and it's a Python, not a pure Python. It's a Python scripting language we are trying to use. And finally, templates. Okay, we have a template. Okay, velocity and even mustache, or even also we can have. So what are the templates? Or if you have, it's nothing but payload generation, right? Payload generation, you can payload or any message content generations. Okay, so using that, you can provide the templates in this location. So this is overall. We call CBA. And so coming back to that flow, we have a CBA, and assume that when we are getting a request for a particular CBA and particular version and particular action. Inside the CBA, you can define a number of workflows. Workflows are mapped to action. Okay, so in that case, we are not defining like LCM API. So LCM API strictly it mandates that action, and because we have an assumption stating that certain VNF may not have all the life cycles. So certain VNF have only one life cycles, and certain cases we want to build a dynamic action, okay, which is not related to any life cycle also. Okay, so that's keeping in that mind. So we are completely giving flexibility to the self-service designer. Okay, you can come up with your own action, okay, and model your own action, and then just make use of that, generate that API and consume that API, so that you can send that request. Okay, that's the idea here. So you can define a number of actions here, and for that action and blueprint and version, and with respect to that input payload information. Payload is nothing but request information. So this is a generic. We built a generic processor, so that automatically based on that, it can understand that it can understand which blueprint or which CBA file to execute, Under the CBA file, it looks for the directed graph based on that action. It looks for the directed graph, and we have already SLI. We made use of SLI in this as a microservice platform. Okay, we enhanced that SLI. Okay, just to have only that execute node, return type, and switch. Switch mostly 4 components. We are not using all the directed graph components or directed graph nodes present there. Just we made. Let me show that in code also later. Fine. So which is relevant, which is required. We make use of that. And based on that workflow action, directed graph will be invoked, and directed graph, inside the directed graph we have a component mapping. So with that component mapping, it executes the corresponding component. Okay, all this infrastructure we built in a reusable way. So so in that case, you don't want to concentrate on the directed graphs executions and the component invocations and rest of the things. It is a common framework actually. And the component framework, it can be anything. Okay, it can be a resource resolution Python executor, or any. It can come up with device specific or device transaction specific. It can come up with that, or it can come up with your own business components. So that's where I have given a highlighter. Okay, certain things we are doing as a platform perspective, and certain, if you want to extend in your own organization and make use of that. During that build up or during that creation of that instance itself, you can with that Maven, simple Maven dependency, you can include all those components okay inside your blueprint processing platform, so that it will be available for you in terms of execution data flow.
Brenda, regarding CC SDK 926, that's to build the capability component. We will be building a component that will be sitting beside these 6 components you are showing us, and it will be called by the component executor, right?
Yeah, exactly. But let me talk about the difference between that component and here what really components we are building here. Okay, in ODL perspective, all those components okay works on SLA context. Okay, SLA context and as well as a kind of bundle OSGI bundle perspective. Okay, we faced a lot of issues in terms of migration perspective. We faced in terms of context data handshake perspective also, and in terms of forming that request and returning that request. Okay, because I think you faced a lot of issues in terms of sending that message or a chunk of payloads which is nested structure, and object handshake, it's not there. Okay, so that's the reason. So we have come up with that new execute or new component function which can handle that object and which can be injected dynamically in a spring-based injection. Okay, not in a bundle-based injection, because that platform itself is completely different. But answering to your question, how we can make use of that? We can make use of that by its jar and removing that bundle dependency. Okay, if you try to look into that, if you're trying to build a particular piece of component, if you are not relying on any of our OSGI dependency, and as well as that other bundles, then you can directly wrap in a component, and then we can make use of that. One good example I could say that SLI. SLI, it's a bundle, right? So we make use of that SLI inside that blueprint processing platform, just by removing or not removing, I could say that just mocking that layer of DB libs, okay, by injecting that spring libs. Okay, we removed like that. So in that case, you can reuse that particular functionality, okay, here, and like that you can do that. And other than that, these 2 components are completely different. Because each takes a different input, and each works in a different data perspective itself. That works in a service context perspective, which is a not modeled perspective. Here we are using a modeled input, and as well as we are using a object handshake throughout that place. I think I extended your question and I explained that your future questions also, right?
We are kind of trying to understand here, but we can resume this talk when we go deep in the code again.
Okay, yeah. I will help you in that, yeah, to make it understand. Okay, so any other points that I want to discuss here before going?
Brinda, I have a query here.
Yeah, Janani, go ahead, please. Yeah.
Yeah, actually, we have dependencies in the component itself, right? Like whom I should depend on and whom I should connect to, like that. So if we have that itself, then why do we require a directed graph? Like directed graph also.
No. Think about like okay, you want to plug a 2 to 3 components. Yeah, your question is valid, but the problem is who will understand the dependency and who will execute that particular process. Okay, we need some workflow orchestrator, right?
Yeah, like I understand in action itself we can provide one single component which will itself resolve it all its dependency on all its connector.
But like you want a self-service, okay? It is not a developer. Whatever the platform that we are trying to build, it's not a platform for developer alone. Okay, it is like a combination of developer and which should satisfy self-service perspective. Okay, so in that case, suppose if you are trying to build a flow, so it means like a graphical representation you need that. Okay, even though you can have a component, one component can satisfy all of your needs. Think about in my scenario, I want to do a resource resolution and then I want to do a configuration of the device. Okay, certain places I want to do only the resource resolution. Certain places I want to do license management and as well as a configuration management. Okay, I want to connect to the device 2 or 3 times. So in that case, I want to orchestrate that flow. Okay, in a model, okay, whatever the model you are having, it's nothing but graphical representation, right? Okay, so and moreover, we need a workflow orchestrator to orchestrate that dependency, right? So that is the reason we are using a SLI. We are using a directed graph execution engine, okay, and as well as a DG. Okay, DG maintains that flow. Okay, what component I want to invoke first and what component I want to invoke next. Okay, so that it can be translated into that model workflow. I believe why you are raising the question because you have a conflict. I think you need to understand about capability requirement dependency is a completely different from orchestration dependency. Okay, capability dependency it talks about configurational dependencies, right? Okay, and orchestration dependency it's a completely the flow level dependency. Janani, you are getting it or?
Yeah. I'm following you.
Okay, so the configuration related dependency only you can manage through requirements and capability. Okay, and flow level dependencies that you can manage only through the directed graph. I think answering to your question simple way.
Okay, I get it. One more query is that this Python executor component is there, or when we want to do some transaction management into the devices, in that case we provide a script. So how does this component is supposed to work? Like, I mean, I want to send a first one template, some payload, and then I want to do this on the device. So how does this component take care of it? I didn't get that part. Like, okay. 5 template.
Can you hold on this question for a moment or something? No, once I get into that particular piece of particular component, I can explain it very clearly. Right?
Yeah, sure.
And okay, so these are all about the data flow. Okay, let me jump into that. Okay, I skip for that UI right now because it's more of how we model and how we or how we try to create that model. Okay, that's a UI decomposition. So for now, I skip this particular portion. And coming back to that, okay, it's very simple, right? So here we are using a Tosca standard. But we are using a Tosca standard for our application orchestration and self-service perspective. Okay, and it's with the dependency we are trying to. Okay, let me explain about. Okay, it's nothing but node and node concepts only completely. So all those entity we are trying to define as a node, and each node has its major two components. Okay, one is capability and requirements. Capabilities are nothing but what it exposes and what it's trying to achieve, and requirement it's nothing but suppose in order to perform a certain thing, what are the requirements that what are the dependencies I could say. Okay, I need to have. So this is overall the concept, right? So basically we call this is a node type, and then node type. This also we can call as another node type. Okay, which may be of different entity type, and one node type can depend on other node type using this requirement and the capability relationship. Okay, you could see this relationship. This is the concept, right? So and one more thing, there is a huge difference between Cloudify and this one. Okay, Cloudify creates the orchestration flow with this model, but in our case we are not using that orchestration flow with this relationship. We are using this model only from configuration relational perspective. Okay, not on that, because I can use any another drawbacks with, I could say. Okay, it is not a drawback. What I am expecting is like in terms of Cloudify, it doesn't provide an orchestrational flow view. Okay, so that's the reason we didn't choose or Cloudify in this case. Orchestration view is not there. Okay, only that modeling view is there. Okay, but not the orchestration view. Here in our case, in a self-service, we need a combination of orchestration and as well as a combination of configurational dependency management. Okay, if we can go with that BPMN. Okay, certain people may ask a question, why can't we go with the BPMN? BPMN provides only that workflow modeling, not that configuration modeling. And Tasca and Cloudify provides only the configuration modeling. So what we are trying to achieve, we are trying to achieve two modelings. Okay, so configuration as well as flow modeling. Okay, we are trying to do that. So that's the reason we are using a Tasca definition, and for workflow you can use a directed graph, or if you want you can enhance your BPMN or Camunda workflow engine. But the problem is Camunda is heavy, very heavy. So in our case, controller perspective, that's the reason we don't recommend that Camunda. So and later point of time we are trying to come up with our own DSL tiny workflow engine, which is required for our case. Okay. So that we can take, and moreover asynchronous perspective and non-blocking perspective. Okay, Camunda is completely it's a blocking and old Spring Boot MVC pattern. Okay, we don't want to do that in terms of performance. Considering the performance in perspective, we are keeping aside Camunda. So that only we started using that SLI. Okay, which is very lightweight, directed SLI. Yeah. So with this model, with these two combination, we are trying to build a self-service CBA file. Okay, so that's the combination of that. Okay, and we make use of the most of the Tasca definitions. Okay, I could say that nearly not 100% of Tasca definitions we are using that, because we don't need that, and we need only out of 60% of the Tasca definitions, I could say. So we are trying to reuse the Tasca definitions. Okay, Tasca version 1.2. You guys can refer that 1.2. So you could see that all the definitions are here. Okay, you can make use of. And mostly here in this release with respect to Casablanca and this release, we are doing a major change. One major change. It's like we are trying to convert into microservice. Okay, all the blueprint processor, whatever the resource resolution component we have introduced in Casablanca, we are trying to convert into microservice, and as well as the blueprint processing platform itself completely a microservice. And we are going with the multi-model file-based architecture. Earlier, if you look into that Casablanca, so we have our blueprint models with a single JSON file, which is a very huge and difficult to manage. So that's the reason, and moreover, dynamic scripting was not there, and artifact dependency was not there. Okay, artifact component dependency, and in this release, Dublin release, we enhanced a lot. Okay, and as well as we have created a lot of a plug and play concept. Okay, you can come up with your own implementation. You can extend at any levels or any layer, and you can customize that framework according to your organization. So in that aspect that we have made that. Okay, I believe that question is not to me. to that, what are the models, the key types information that we are using?
I can't hear you. I can't hear you. I'm
Guys, please, if you are not active, just can you please mute? Yeah. Controller, what are the types that we are using? I have documented here. Okay, you can take a look. Okay, so I think most of the people know that. Okay, and once I get into the template, I can explain that. Okay, so on high level, we are using a relationship type. We are using topological template, and then using data types. We are using artifacts, and then imports we are using. And all those, what are all the things that we are using? It's documented here. I think you can go ahead. And certain things that we are thinking of implementing that policy, okay, policy which is mostly useful for authentication, authorization, and in terms of response, posting the response, or in terms of events to generate. Okay, still we couldn't materialize properly, so it is under discussion, right? Certain policies. And certain functions we have already created, like a get input, get property, and get out operation output, get artifacts. Okay, so certain operations that we have implemented, so which we can make use inside the model itself, inside the CBA itself. Okay, that's all about. I have that, and this is about SLI, which is not relevant in this case. Okay, or not part of this agenda. Okay, before moving into the code, if you guys need any architectural queries, if you have any architectural queries.
Yes, Brenda. Can you please go back to slide number 5? It's Kirill speaking. Yeah, and question regarding the way how we interact with AAF framework. So basically here you put that we only interact through CDS UI. There is no direct interaction with blueprint processor and controller blueprint between AAF and blueprint processor. Can you please explain your thoughts behind that?
Exactly. Let me talk about that a little bit about AAF. Okay, Blueprint Processing Platform is a common platform, right? So all those APIs, okay, whatever we have, it's a common API. Okay, only certain VNF owner should execute certain blueprint. So it means like, okay, we should not enforce AAF on REST API endpoint. We want to enforce authentication and authorization on a blueprint execution perspective, on each execution perspective. Since we are using a dynamic API, okay, so it means like on API level we want to do that authentication and authorization. Okay, so that's the reason we need to have that policy. So inside that policy or workflow property, okay, we want to have a workflow property or policy. We want to define that, okay, that particular user role, what all the user role can access or can perform that particular action. Based on that, okay, during that processing, whenever Blueprint Processing Platform gets a request, okay, it understands from that model itself who are all the valid roles, and it has to collect that principal or credential informations or what kind of roles for a particular user, then it has to validate. So here that AAF authentication and authorization is slightly different when compared to other microservice. Okay, so that's the reason we are having a gRPC. Okay, gRPC uses a common certificate, TLS-based certificate-based authorization in terms of accessing that common processing API, but not that action APIs inside that. Okay, inside that action API will be handled by AF and connection. Okay, connection security will be managed by the gRPC. Or it's like a common, we can define one role with respect to the AF to define a common roles in order to access that API, but not at blueprint processing, blueprint action related API. I think you guys are you're clear.
Okay. Just wanted to confirm and make sure we are on the same page, that there is no direct interaction between blueprint processor and controller blueprint to AAF. All interaction goes through CDS UI server layer.
No, yeah, you want to understand my point actually. Okay, here. Okay, if you are trying to make use of a gRPC, then I think we don't need AAF. Okay, for gRPC kind of communication from controller blueprints to blueprint processor, then we don't need AAF. We need that AAF, okay, in the request processing level, not on interaction or not on interfacing level, right? You understand? Yeah. Okay.
Yeah.
Okay, if you're going to gRPC. If you are going to REST, since blueprint processing platform, it has two ways to connect. One is gRPC and another one is WebFlex API, which is a REST HTTP2 based API. So if you are going through HTTP based API, okay, then you want to define one common role, okay, which you should connect, and that role should be possessed from it has to be defined by all the users. Okay, all user roles should possess that value, or high level SO should possess that particular role that it can connect. But internally, in executing that blueprint, it should be certain role. Not all should execute. Right? You are getting it right?
Yeah. Okay.
Guys, do you have any topics that we want to discuss this AF? It is a little bit tricky here in this case. Okay, just move on. I will move on that later. We can have these discussions also. Yeah. Okay, let me go on to the code level. Yeah. So we have as I explained that, okay, right now we are going to concentrate on the only two other than that UI, okay, UI later point or in other meeting we can try to discuss about that. We will talk about only the controller blueprints and blueprint processor, two different microservice. Okay, under that we have application. Okay, application is the security related and configuration related information. It is going to be in application. And distribution, it's just nothing but distributing your package. You can manage your own dependencies, okay, with respect to organization. You can tweak and then you can add your own dependency with this distribution. And then modules, we have a reusable modules we have here. Before that, I want to explain about components. Okay, so components, we have a core component which is nothing but which holds all the blueprint data information. Okay, one core thing that you want to see is like this is a blueprint model. Okay, so I have defined that task annotations also, task number from you can take that reference number and all the task definitions. Okay, we have documented. It's like mapped to a bean actually. So this is what we have done that. So this is a core file, and we have that certain, right? Okay, this is a blueprint, right? So this is a core model which has a certain interface information, which has a catalog, which has a enhancer, which has a function. Okay, suppose if you want to create a function node, then that interface, okay, function, and then scripting service. Okay, suppose how to call a scripts, and then repo service. Okay, it's model related services. Okay, how getting from the database. Okay, and then validation. Okay, validating that models. Okay, all those definitions and interfaces are defined here. Okay, that is called a core. And one more changes you may expect that core may move to controller blueprint modules. Under the modules, that core may you can see that change in future. And as well as a resource dictionary. Okay, resource dictionary is meant for completely handling the resource dictionary, resource definitions. Okay, I can interchange that. I interchange the word resource dictionary and resource definition because dictionary is a common people may use in a lot of places. So here we want to stick to that resource definition. Resource definition, I think you all guys know about that. Resource definition consists of okay, the nature of that particular resource, okay, data type, mostly the data type and optional samples, and the constraints like range, okay, and color expressions, type definitions, all those things. It's a dictionary, and along with that, it should have that possibility of resolving that resource. Okay, so during a transaction flow, okay, that particular resource can be resolved with the system X or system Y, and then it can resolve, or sometimes user may pass that input also. So all those definitions are here, and we have certain modules, utilities, and services in terms of enhancing, in terms of identifying the dependencies. Okay, all those informations are there in resource dictionary. So we separated as a core and resource dictionary. Certain people, they want that core, they don't want resource resolution capability. So in that case, they can use the core alone, not a resource dictionary. If they want to reuse that both core and resource dictionary, then they can. So these two modules you can expect to be part of a controller blueprint under modules later point of time. Okay, this is one thing. And we have another module called script. Okay, the script modules, it's basically a reusable platform-specific scripts. Okay, not self-service scripts. Okay, this scripts provides a glue between our framework and your Python, your Jython scripts actually. So which is nothing but reusable utilities present in a Python way, and constants. Okay, you may have a constants. You may have a interface so that all Jython script should follow that in order to achieve a better result and the standard format. Okay, so certain things are defined here. Okay, one good example I could say is suppose if you want to create a component, right? So in that way you want to extend that component called abstract Python component. So in that case, you have a method called a process and recovery. Okay, so you have an abstract component here defined, which extends that abstract component function from our framework. So which is defined in a JVM perspective. So some framework related, okay, is reusable across. Okay, so that script will be here, and this will be exported during the platform, during the Docker image creation, and it should be set into that path. Okay, by default, this wherever you are trying to export to that Docker, and this path should be set into that Jython execution path, so that in order to make use of this framework, okay, make use of your custom. It's like you assume that it's a custom pip model, your framework pip model. Yeah. Okay, and coming back to that model catalog, we have a model catalog, and here in this case, okay, we have a blueprint models. Okay, as you all know that we are dealing with the reusable models here, and it should be version control. So for that, let me talk about the definition. Okay, definition. So we have a starter type. Okay, starter type means by default these are all the definitions will be loaded to your designing platform. So we have artifact types. Okay, say for an example, in this case I want to show velocity template. Okay, so this is nothing but it's a definition. It follows a Tasker definition. I'm trying to create a definition for a velocity file, velocity template. So in that case, it possesses an artifact called implementation, and then extension of VT. And if it is of Kotlin, okay, we have a KTS scripts. Okay, and then this is a root script. Okay, root Python. And if it is a mapping, then mapping it's a JSON implementation mapping file. Okay, and if it is a directed graph, it may be XML or JSON. Okay, most probably in our case we are using XML, and later we can use from JSON itself, if possible we could convert or dynamically generate XML. We can make use of that. Okay, right now we are using XML. And for resource dictionary also, it is in JSON format. Okay, so we have that. So it's a definition of that artifact. Similarly, data types. Okay, so we have reusable data types. Okay, and so mostly that database property and the data resource resolution and certain things, it's reusable, so we can have it here. Don't it's one more suggestion, right? Don't put all the properties, all the data types which is relevant to certain services inside here. Okay, so for that we have a separate. We can create your separate context, and then we can create a one more called service types. Basically, under the service types, you can define your same architecture, same types, and then you can put there. In that case, it will be easy to manage, and then you can build your own instance. Okay, specific case by cases also. So in that case, you don't want to end up in creating and putting all the models in a single place. You can create your own instance and customize your own instance also. Okay, and node types. Okay, here starter, assume that starter is nothing but a default or reusable, and which is applicable for any instance you are trying to create. Okay, so that's the perspective we have. So we have our definition. And one more, why we are trying to build this, it's like mostly our aim is to reuse the definitions, and during the designing we should not get a confusion what to use and how to use. That's the reason. If you try to look into that ASDC, so this complete modeling we want to do it. Okay, we want to define a types and then we want to create a node templates. Okay, but in this case we are not going to let you to define the types. Define the types. It's already defined here. You can make use of the type so that it's well organized, and then it is already implemented. Okay, and it understands the definitions, and it can work better. Okay, so some cases no, we can't allow free to model types in terms of based on that underlying components only. You want to expose that API and expose that model, right? So that's the reason we built like that. Okay, and more of a reusable perspective. So we have a components. Okay, suppose if you are trying to create a component and you can model that component. Okay, one good example is like resource resolution. So we have a component and we design that component in this fashion. So which takes the input name. You can always it is up to you. Okay, you can modify inputs and outputs based on your component definition. It is not like we want to follow the same thing. Okay, based on our implementation, you know that what all the inputs to take. You can model and then you can inject that model here so that it will be available for you. Okay, suppose if you want to tweak that resource resolution, think about like you want to tweak that resource resolutions and you want to put a custom components, then you can define your own component. You can extend that resource resolution component, and then you can put your own bundle. Okay, and by skipping this dependency. Okay, skipping this dependency, you can have your own dependency, and you can modify that input so that it can take that input whatever you have modeled. Okay, and you can process that function with respect to your organization and your organization needs. Okay, and like this we can define that node template. On high level node types, we have a component, we have a device, and then we have a directed graph, right? So high level node types we have that. One is a directed graph generics we have. Earlier we wanted to design each directed graph, but in order to have a simplistic design, okay, we have defined a one directed graph node, so where you can model completely altogether. So that's a one DG generic we have. And then we have sources also. Suppose for an example, in this case we have defined a certain sources, okay, certain reusable sources, but inside your organization you may want to connect to one resource for certain resolution of a particular resource. So in that case you can model your source system, okay, like that, and you can place it here, you can place it under that under the model and make use of that. So it's highly configurable. You can make use of very easily. Okay, and we have components. Okay, component based also, and then we have a directed graph and one more VNF. Okay, here I have given that VNF netconf device. Suppose if certain device has a netconf and SSH capability, you can model that netconf SSH capability, and you can define your capabilities. Okay, I have defined only netconf. You can define your own SSH capability and define the properties, what are the properties you want to collect. Certain organization may need a different login account and different way of getting that user credential information or device credential. So in that case, you can define your own model and extend that particular piece of component and make use of that. Okay. So,
Linda, you mentioned that this is currently only on SSH, is it?
Yeah. Right now we are building only on SSH. Yeah.
Can we have the configuration where this is being marked as SSH? Because I think the extension for CCSDK 926 is for configuration step over TLS, and
yeah, exactly. Okay, it is up to your contribution actually. Okay, just I will go through that point actually. Okay, I will take this point and then I will try to clarify this. Okay. Before I want to just give that information about that architecture and the models. What are the models that we are using? That I can speak about later. Is that fine?
Yes. Thanks.
Okay. So in that way, suppose for an example, if you are trying to build a new RESTconf component or function, we could say the component or function interchangeable, because our ultimate aim is to trying to build a serverless function in future, That's the reason I'm trying to say that component and function interchange function and component together. And moreover, if you look into that, all the functions, it's a separate standalone. Okay, there is no dependency other than that abstract model. Okay, if you go inside that, okay, it uses only that abstract model dependency. So it means like you can develop this function alone and you can test it alone. Okay, no need to be a part of a platform. You can have your own data access and own configuration completely altogether. It can be a separate application altogether. And bring the dependency. If you want to run the dependency to be part of the platform, then bring it and include it in a dependency so that it will be part of. Suppose in this case, okay, we want to build a new REST-conf adapter. So what you want to do is you want to create a function, mimic this any one of the component, and in certain cases, what's the thing is people, they don't want to use that dynamic scripting also. Okay, I want to directly interact with the device. Okay, I know the specific function. Okay, I don't want to have a dynamic model. In that case, you can define your own resolution component, provide your implementation just by extending only one. Okay, let me show only one interface, right? Okay, so that interface, yeah. Okay, you want to extend only one interface or one method or abstract component function. So in that case, if you extend that, okay, why? Because we are standardizing certain things. Okay, that component should have a recovery plan and as well as a processing plan also. So that's the reason we want to mandate that. Right now it's completely it's stateful and there is no recovery plan inside that, even our directed graph and all those things. So we are planning to build like a state machine kind of concept. So in that case, if there is any failure, we want to recover that. So that's the reason we want to mandate certain things. Okay, so just by including that abstract component function, so in that case, you should definitely, you will be in position to recover if there is any failure. Okay, just extend this and then provide your own implementation. And by default, you will have that all the execution inputs. Okay, so in that execution inputs, you will get all the information, relevant information. And if you look into that top abstract component function, so it has all this information, right? So it knows like what is the workflow information and what is the current step. Step is nothing but current component reference. And let me, before going into that one model, okay, before going into that, let me find one model, right? So just I have 5 minutes. How I want to continue this? Whether I can continue for Yuri? What about our meeting timings actually?
So I had this meeting until 11. So if you have until 10:30, what we can do is have a session on Thursday, same time, 9 to 11.
Okay. Okay. It means like I can continue for another 30 minutes.
You have 30 minutes.
Okay. Okay. Sure. Then I can. Okay. So let me go through that before one model. Blueprint models. Okay. Similarly, for blueprint models also we have a service-based models. So in that case, you can bring your own service-based templates. Okay. Here the place where you are trying to build your own use case. Okay. So one is a virtual firewall. You can have your own models, and this is a starter template just to give, or suppose if you don't know how to create a new model. So in that case, no. By starter template will be loaded for you, and during modeling you can clone this model and then you can create your own use case. So for that purpose, we have a base configuration, and then test blueprints. Okay, and some cleanups we want to do that. It shouldn't be a zip file. Okay, the same. Okay, just for testing, unit testing perspective. Okay, we want to move. We are using a base config for all unit test perspective. Just what we want to do is like we want to move that base config here, and we want to refer that test blueprints, and only we can have a starter blueprints here. Okay, that we can do at the end of the. Or once everyone settles down or everyone understands that. Okay. So we have a base configuration, and then this is a starter template which consists of a universal model, I could say. Assume that it follows the same Tasca pattern, right? So Tasca, if you look into that Caesar file, it should have a Tasca meta folder. Under the meta folder, it should have a Tasca.meta. That definition defined in this Tasca. Okay, this definition we have that at the bottom. You could see that definition for how it should be. So we have a Tasca meta and Tasca meta file, and then here it should have that file, and then it has a creator name, it has an entry. So entry definition is nothing but the starting template. Okay, where what is the actual blueprint. What is the actual blueprint? Control of blueprint file. So, and template tags are nothing but searchable queries. Okay, this is searchable queries. It is not needed. These are all not needed. Okay, you can include that, but only high-level information. These are all mandatory information, right? So we have a mandatory information, and based on that, it understands that this is a high-level blueprint. Okay, in the high-level blueprint, first section this is a mandatory. Okay, you need to have a template author email. It's like extra property. I think still we haven't decided like how the template author type should be. It should be name along with email, or only name, or only ID. Okay, that we can take it later. And user groups also, it is not needed, because a later point of time we are planning to have that user role not on model level. Okay, you should have it on workflow and action level. That's the reason we can deprecate this one. And template names we have. Okay, this is mandatory. Template version, it's mandatory, and template tags mandatory. Okay, these 4 fields. Okay, it's a mandatory. Okay, right now. And next to that, we have an import section. Okay, import section, it's I believe that most of the people know that a task definitions very well. Okay, so we have a type. Type is nothing but it talks about that nature of that, what all the properties should come, and what is the nature of the property. And we have a node template. Okay, one is type, one is template. Template is nothing but instance. Assume that you have a Java class. Class is equivalent to type, and instance of the class is nothing but template. Okay, in a simple assumption, in a developer world perspective. Okay, so we want to tell that what all the types. Okay, so as a simplicity perspective, and we don't want to dump all the types inside the main file, because this is a core file where user will try to concentrate. And type file we don't want to concentrate, because it is a reusable and coming from that enrichment process. Okay, that's the reason we have separated out to a separate file. Okay, which is called a file. Automatically you could see that. Okay, all the type related files we have, and you could see all those files also. Okay, simple one example, it's artifact type. Okay, so what all the artifacts that I'm using inside that model, inside the blueprints. Okay, here it has a definition for that. You could see that. Okay, in this model I'm using a velocity template, a mapping resource, JSON, okay, directed graph, and components. Okay, that we are using that. All those you could see here. And then I will come back to this later. It's a similarly data types, right? Suppose if you are trying to model a new type and then coming up with a new types which is used inside a template, and or else which is used in your transaction. Okay, so if you are trying to define a new data type, and all data types will come here. Okay, and node type. Okay, all the node types. Okay, what are the instances that we are trying to create, and relevant for node template, node types will be here. And it is mandated that if you are trying to create an instance, then type should be defined and type should present inside the file. Okay, so until the root level itself. Say for an example, here think about like a node strategy. Okay, this is derived from node strategy, and then it means like a node strategy should the type also should present, right? So this node type derived from that. Okay. And just let me explain that one component, one node type, so that it will be very clear how we are trying to use that. Okay, and in this case we have a component. Okay, component has interface, right? Suppose if you want to interact with the component, it means like we need to invoke that component, right? How we want to invoke the component? Invoking that component by using interface, right? So in this case we are using a interface, and then we are using that component name. Okay, we are having that, and then operation name. By default we are using the operation. So even though it supports a multiple components, okay, even multiple interfaces, we can define that. Here we mandate to that one, because always it should have extend that abstract. So always we are trying to define that only one component present here for now. Okay, at least for now. And we should have that operation. By default it should be a process always, because we already inherit that method called a class called abstract component function. So always it's a process function. And you can define your own inputs. Okay, you can define your own inputs. And entry schema, I think you all know about that. Okay, entry schemas, suppose if you are trying to define a type as a non-primitive value, it's like array or array type. Okay, then it's like you can define a type of list, and then you can tell that all those definitions, we are following a task model, so there won't be any confusion if you go through the task definition. Okay. And similarly, we have here the takeaway point. It's like for a component, we need to define interface and then interface name and operation name, inputs and output. We want to define that. Okay. And we have a requirement also. Okay. Requirement is, as I explained already, component should have a component. You should have a component, and then component should have a suppose if it exposes some capability, it is a capability. Suppose if it depends on certain thing, then it's a requirement. Okay. In this case, this component depends on the network connection. So we have a network connection and then capability. Right now we are supporting one-to-one mapping, and going forward we will support multiple mappings. It's like suppose one component depends on multiple connections. Okay. In this case, we are trying to connect with one device. Later point of time, if you are trying to connect with multiple devices and if you want to configure, then occurrence will come, and then based on that occurrence, this capability name will change to iPhone 1, 2, 3, 4 in a sequence. Okay, just at a high level, don't go into the deep. Okay, so requirement is nothing but okay. Suppose inside this component, we want a certain property in a configurable way and in a modelable way. So that's the reason we are using using the requirements. We can do it. In that way, we can try to get that property information effectively and quickly, effectively by using this reference actually. Okay, and finally, so let me talk about one instance. Okay, so for this, okay, whatever I have explained just now, it's a type. Okay, we want to show about one instance, right? So one instance, it's a resource assignment. Think about in this case. Okay. So we have resource assignment. So resource assignment, you could see that this is a type. So it means like there should be a type definition for this okay, component resource assignment. We always follow some it's like a pattern. Okay, if it is a component, always it will be a prefix with the component, and if it is a directed graph, always prefix with the directed graph. And if it is a VNF, okay, VNF device or something, we prefix with VNF. Okay, so in this case, so it is easy to understand, and by looking itself, we will come to know that that's the reason. So type, we have a component resource assignment. It means like this type belongs to that component resource assignment. So that you can take here, right? Component component resource assignment. Okay, so where we have interface definitions and we have all these informations, right? So based on that information, so you are trying to fill them. Okay, here you could see that expression. So action name, even you can hard code that value or provide an expression. Okay, as I already mentioned that we have already defined or implemented that expression, get input, and then get property and get attribute and get artifacts. Okay, mostly we already defined that. Okay, and attributes are dynamic information. Okay, which means like it can be resolved inside that particular component, which is similar to that service logic context. Inside that execute node, you try to resolve a certain property and put it in a context so that it can be referred by other property or other components. Okay, so that we call like attributes. And then property, it's nothing but it's a static property which is defined in a node, in a different node. Okay, all those informations are documented in task definition. You can make use of that. You can get those information. So in this case, what I try to see here, you could see that this is a hard-coded value and this is the expression value. So in this case, you can define both expression and hard-coded value. It understands from that information. And this is array, right? You could see that array of information. So based on that, being a component owner, I know that what input to take and what output it will return and what it will set. Okay. Right now, what's the thing is, as you know that, okay, that node has its property and attribute definitions. We have mandated that property. Okay, property should be defined upfront, and artifact it shouldn't be defined upfront, but we are also going to mandate that attribute also defined upfront, so that it won't break that flow. Okay, break that flow, and even we can do the validation of that attributes. Let me correlate with that existing flow, how in directed graph. In directed graph, we have a context property. We set a context property, but that is not visible. Only developer knows that what context property it is set and how I can make use in other component. Other than that, nobody knows about that. Since we are dealing with modeling, okay, it is a mandated. We want to mandate that what are the property that you are trying to set inside, and as well as we need to upfront define during that modeling itself, okay, or during defining the components itself upfront. You want to tell that, okay, what is the dynamic property you are going to set inside that, and then based on that I can make use of that. Okay, say for an example, assignment property that we are going to have inside that. I'm going to create that assignment property, going to set inside that component. Okay, so what's the thing is I want to, so I'm trying to make a point. This assignment property should be defined upfront, and it should be documented in node type. Okay, node type. We have two sections. Okay, so let me go that section. So, yeah. Okay, node template and node type has a property and attribute. Right now, property is mandated. Property defines all the informations, and attribute keeping as a dynamic. So we don't want to have that attribute to be defined, but we are going to mandate that attribute to be defined. So in that case, it will be useful for self-servicing, and understand that what property, dynamic property, I'm going to set inside the component. Right. Whether you guys are following whatever I'm trying to say,
Overall, we understand the concept, and I have seen before this meeting how the flow is bound to Kotlin classes through the component annotation, and by using the name of using the name defined here. This, I think, we will have to probably watch again the recording of this, and it will be more clear when we start working with our version. But the basic idea and intention we are getting, although what it's mapping to, it's somewhat unclear to us at this moment, but it will be when we start working with it.
Sure. Yeah. Okay. Then I think this is all the information I want to share with respect to that model. And let me talk about a little bit about data dictionary also. Okay. You all know that, right? During a process, we want to define we can make use of a resolution capability. It means like it can go to multiple systems and it can resolve, and it can keep the data in the context. Okay, so for that only we have a resource resolution component. We have that, and all those things managed with the model. Okay, so how we are trying to manage it basically by two different files actually. Okay, if you try to look into that node templates, okay, let me go back to that. Okay, resource resolution. Yeah, in this way we can make use of that reference, right? As I explained earlier, node type, node templates. Okay, node templates can have an artifact definition, and then artifact definitions we can define any name. Okay, and in this case, what's the thing is we have we will document that. Okay, we have in order to, because template and mappings go in hand. Okay, so that's the reason we have a template and a mapping file. Okay, all together. We have a templates and then we have a mapping file. Okay, template is nothing but a JSON file, and mapping file is like how I'm going to resolve that resources which is needed for the template file. So that's the reason. And here you could see that point. This is more component functionality. Just I'm trying to explain that. Okay. In this component, I am trying to resolve a certain resources. Okay, and trying to mash with the template and trying to create a payload. This is the idea here. So for that one resource resolution, I'm using the base config. So by default, it understands that base config template and base config mapping. Okay, that should be a mandatory. Okay, it should have a template and mapping file should be present there. And it is mandatory, but certain cases what will happen, the template it will be a self-contained. Okay, it need not to resolve. Okay, it will be a simply hard-coded value also. That's some configuration. Okay, so in that case also just to define a file and don't keep any mapping of the file, because based on this information only it will try to understand that what all the mappings and resource resolutions needed for that. Okay, So we have a file, and that definitions you could see here, base config template. Okay, we have a base config template. So here you can define your own templates file, and then coming back here, we have a base config mapping file. So this is a mapping file. Mapping file here, it's this is a mapping file. So which contains information about what is the name and what is the property, okay, and what is the dictionary name we have that. Okay, so here you see the dictionary name. Okay, that dictionary name will be this information will be provided by resource definition type. Okay, so here we have one more file called resource definition. So what all the resource definitions that we use inside that model, that will present here. Okay, this is a common reusable file. Even you can have a number of mapping, but you may have only one resource definition type. Okay, so that one resource definition type will hold all the information about that. Okay, all the information about what all the templates that we use it here, and it can make use of that. So in that case, so service instance ID, if I'm trying to look for service instance ID, then automatically it can look for service instance ID. It can take the definition, so it can understand that. Okay, what is the name and informations and what are the possible sources it's available, and even dependencies also you can get into that. Okay, based on the type it can understand. Okay, suppose if you have input, then input property definition, and if it is of a data source, okay, database related or REST based related, then it has a REST based related. Okay, so that all those definitions already, I think you have seen that. That is defined in a type file. The definition, right? So in that definition, no type, okay, based on that source type. Okay, so here it has a source type, right? Source REST. Okay, source REST means it has a source REST. Okay, and then suppose if it is a source input, then it has a definition. What are the content present here? It maps to that source input. It has only the key and the key dependency. So that's the reason you should have that key and key dependency. I think. It is not needed for input because name is mapping here. Okay, let me talk about REST. In this REST, it has a type. It has a URL path, a path expression type, and similarly, you could you could see that type URL path, and expressions based on that. Okay. Yeah, that's all. That's in this way it maps that. So it means like in that resource resource definition, it's nothing but a dictionary. What all the resource definition that we are using, it is going to be present here in that resource definition type, and then a mapping file holds that. Okay, how I'm going to resolve that resource. Okay, out of n possible source system, here you are doing that designing itself. You will tell that how I'm going to resolve that resource. Okay, so with that resource, you have that information here, service instance, VNF ID, VNF name, and even you can manage the dependency. On live itself, during that modeling itself, you can manage the dependency. So in this case, the dependency, we have a service instance and VNF. So it means like it understands that before resolving this VNF name, it should resolve that service instance and VNF ID. So it knows that, it understands that. We built that DAG algorithm to automatically understand the dependency, and as well as we build a batching process also. Okay. So in this way, it tries to understand that, and it tries to resolve that resource, and finally it creates using that data. Okay, this data will be used in a template, and it will be mashed. And this data, the JSON data, and it will be mashed together. Okay, that implementation, you could see that the mashing implementation is present in service, right? Okay. Sorry, I'm looking in the wrong place. We have a template service, right? This is velocity based template service. We have that. Okay, later point of time you can include that any template services. You can include any template service, and we can make use of this templating service inside it. Okay, and along with that velocity, you could see that here string utils and boolean utils. Okay, suppose for an example, velocity to process extra utilities. You can come up with your own utilities also, and you can use it in a velocity by passing that additional context. With this additional context, you can inject that information, and you can use the same utility. Okay. For more information, you can go and look into Apache velocity, so you can get a clear picture about how to use that velocity template. Okay. This is all about resource resolutions and data dictionary and mapping and how it is related and how we can make use in these definitions, all those defined here. Okay. And I have 10 more minutes. Whether I want to take questions or I can move on to next.
Questions about what you said? Not really, but would you want to discuss the questions about how we can run and how we will design these new components on Thursday meeting?
Sure. Yeah, I will explain that.
Okay.
And meanwhile, just I want to give that if there is no question, then I will talk about a little bit about coding on how component will be invoked, and then how directed graph will be observed, and what are the requests, how we are trying to get. And that I can explain if you don't have any other question.
Okay.
Okay. I believe then I can proceed that. Okay. Now I'm not going to concentrate on that controller blueprint design. Okay. Anyhow, because people are more worried about the processing platform. Okay. Just let me take that or try to explain that processing platform. So we have a common. Okay. If you look into that blueprint processing platform, similar to that application, we have application just to provide a configuration, because no certain organization may use a different way of handling the configuration. And certain people, it's like security also in terms of logging, in terms of filters. Okay, so they want to have that. So that's the reason we have a application. But we don't have any. The point here, it's like we should not put any business logic or any. Only the configuration relation or configuration information. Okay, should go in application. Okay, so that that should be very clear. And distribution, it's a pure of building a Docker image. Okay. And so you can include your Docker image, and you can manage your own dependency. You can filter it out, and if you want to export your own certificates and all those things, you can do it here completely. Okay, these two are organization specific and organization customization perspective. Okay, and function. Okay, it is up to you. You can sometimes what's the synchronization mechanism. Okay, is what if you have a direct ONAP synchronization mechanism inside your organization. Okay, you can completely have as it is, and then don't build the Docker image. You can build a Docker image with a separate project, okay, inside your organization, and have your own functions as a separate project inside your organization. Okay, that same architecture, function as a separate project inside that organization, and build from there. Some people, some organization, they want to build internally, make use of this folder structure, and they want to build that. In that case, it will be very tough. Certain cases, no, it may break your functionality, and it merge conflicts. A lot of issues will be there. So what the recommendation is like, you can have a blueprint processing platform and create a similar project inside your organization, and use only the dependency. Okay, That's the reason we have a parent form. Okay, inside the parent form, we have all defined that. Okay, dependencies, so you can manage with respect to your organization, what kind of versions you want to use and what kind of releases you want to use. All those you can make use of the parent form. And another good example, it's like a function. Already we have defined a function, and inside that organization you may end up with multiple functions. So you can have your custom functions, or if you guys recommend something like that, then I can create one folder called custom functions and leave empty as it is. So that inside you can build inside that application during that merge, you can just try to ignore that particular merge, and you can inside that organization you can have, because most of the challenge that we have, it's like how we are going to take the code and how we are going to enhance the code for our need actually, or for our service provisioning. So we want to think it in aspects of both even development perspective, also even taking the functionality and putting the functionality to and fro. That's the reason we are trying to simplify the solution, and we are trying to, even though certain model structures which is not needed here, we are trying to have a multiple model structure in order to have a clear separation, and you can manage your dependencies, whatever is needed for your case. Okay, and in this case, okay, similar to that commons, under the commons we have a core. Okay, core is nothing but reusable exceptions, okay, certain utilities, okay, all those things that you can define in a common core, and even a common data you can define here. And dblib, okay, here what's the thing is, okay, here one example we have provided, it's a primary lib, primary data source. Okay, so in order to run this blueprint processing platform, at least we need a minimum one database connection. So that database connection we call like a primary database. So that primary database we have that. So we separate it out with that extension package name called primary, so that it won't conflict with others. So you can manage your own repository bean as well as the entity bean separately, as well as services also separately together. For an example, you want to handle a new data source. Okay, so in that case, how we want to do it's like you can extend that, okay, db.db1 or db2 or secondary or tertiary, or you can define the package so that there will be a clear separation of the packages and as well as the domain. Okay, in this case, whatever relevant for this platform, okay, we are putting in a primary database, and some may even certain cases, what's the thing is, some people want to install their own custom tables on the primary database. So in that case, you can also go ahead and do along with the primary, but you want to manage as a separate project or a separate SQL file, .SQL file, okay, separately. Okay, and if you look into that, everything is a configuration based. Okay, so it means like whatever the properties, okay, all those properties are defined here. Okay, let me take one. So we have a clear separation between, okay, blueprint db.primary. So suppose for an example, I want to get a primary database configuration. So this is usually we call selector. So with that with the primary, we can get all the configurations inside that core. So that kind of implementation you can see in that configuration how we are trying to get that. See here, primary prefix you can. So if you are trying to come up with a new data source, okay, and either you can enhance this project or you can have a separate project, okay, for your need, okay, and similarly, okay, you can define your own prefix and to collect that information and make use of that. Okay, and completely configuration driven. Okay, we have that. So it means like we have right now the support is for MySQL. Some organization may have a different database like Oracle on certain things. Okay, then they can similarly they can create their own configuration. Okay, that primary data. I have created a primary data source for MySQL. It's nothing but MariaDB. Right? MariaDB we have created. So similarly, if you have Oracle, then you can ignore this project. So that's the reason we have a configuration. So here enable property, we can enable the property. Okay, just we can enhance this property. Okay, once this property primary data source is true or enable, then we can do that. So in that case, we can enable and disable this primary data source. Right. So that's the reason we have a configuration. So it means like it's more dynamic. If you want to disable this particular dblib or restlib, okay, so it can be easily managed with the configuration. So in that case, we can manage very effectively. Coming back to that, okay, we have a similarly the REST also. Okay, REST we have that. So which takes a multiple configuration, multiple ways to access the REST. Okay, one is the simple base authentication. Some use SSL, some use different way of accessing, some use custom headers. Okay, some use OAuth tokens. So based on that implementation, we can come and enhance. If you feel that it is a reusable and platform specific, you can come and implement here. Okay, based on that. If you feel that it's a custom and more organization driven kind of thing, then you can implement or you can create your own custom REST lib for your case and just inject that. Okay, everything is injectable. You can refer that definition. So that is the REST lib. And coming back to that, the service. Okay, so I have 4 minutes, but let me explain that. Okay, so we have a high level DG executor. So assume that. Okay, before that, let me talk about inbounds. Okay, inbounds are nothing but northbound. Okay, northbounds or inbounds. The mapping, I'm trying to map that ODL to here. Okay, inbounds are nothing but northbound. Okay, don't worry about this resource resolution API. Only we are using a self-service API. Under the self-service API, we have controller. Okay, controller is for REST-based. Okay, as I said, that REST-based. So we have a upload and a process. Okay, we have two methods, and similarly gRPC also we have a gRPC handler. Okay, gRPC handler. So upload blueprint as well as remove blueprint and save blueprint, and final one more thing, process will be there. I think yeah, it is there. Just go and look into that process. Yeah, process. So here we have a gRPC handler, and then that configuration we can manage here. That configuration. So here in this case, okay, here gRPC server. Suppose for an example, I can include a new gRPC. You can come up with your own module, right? So own implementation you can come up with here, and then you can add the service here. Similarly, okay. So in this way, you can add your endpoints, and you can customize your endpoints, and what all the endpoints to be part of your platform, you can manage here completely. Okay, and coming back to here, so it has all functionality for getting that CBA file as well as dumping into the database, and as well as it has a capability to process that. Okay, so once it receives that request, okay, handler, it receives a request, it calls directed graph execution service. Okay, you could see that. Okay, directed graph execution service, and catalog service is just to get that content from database. Right, that's we have a catalog service. And configuration service, it's like a core configuration. Okay, mostly the property. Okay, where exactly we want to extract. Okay, where we want to put that zip file, where we want to do the processing. All those definitions are defined in a configuration file. And catalog file, we have it's a database related activity, or downloading that CBA file related activity. And execution, it's finally executing that. Okay, once it gets a request, it calls that DG execution service. Okay, so that comes here. Okay, DG execution service. Okay, DG execution service, what it is trying to do, it is trying to get that action identifier, action information. From that action identifier, it gets that information, and from that action identifier information, it understands that what is the workflow name, and from that workflow name, it understands that what is the directed graph, and it calls a directed graph. It takes the directed graph and converts the graph into instance, and then it executes the graph. Okay, and we customize that SLI little bit. Okay, so just here you look into that executor. So we have a component executor. This is the component executor, right? So in this component executor, okay, what we are trying to do, once it reaches the node. So this executor node, I think you guys know about that. Okay, it is a SLI framework, and then whenever it hits a node, and this will be called, and we already injected that service information already here, blueprint service logic service information. You could see here. Okay, whenever execute node hits, then we have a execute node that is nothing but execute node whatever we inject. So based on that, these are the only nodes we are supporting here. We are not supporting all because it is not needed for our case. Only execute node, block, return, break, and exit. Okay, we have that. Okay, whenever it creates execute, I think I need to stop 11 o'clock. Yeah, if you don't mind, I can take 2 minutes to complete this. Okay, we have that execute node, and then this component execute node we have. In this component execute node, we have we are trying to execute that particular component. How we are trying to execute? From that plugin, we are trying to get that instance name, and from that instance name, we are trying to get that corresponding abstract function. Okay, what is the function? It's for that corresponding to that node, and now we are passing that. We are creating that some inputs. Okay, which is relevant to that. Say for an example, node type and interface type and operation. Okay, and creating a step input. Okay, here where exactly we are using a blueprint runtime, and we are trying to resolve that expressions. Okay, assume that in a blueprint you have defined that input and the input with expressions, right? So we are resolving that expressions and then setting that expression output value as a node template name, that step inputs. Okay, and then we are passing it into that blueprint service context information. So this inputs will be available there. So with that inputs and with that actual input, okay, you have a step input. Step input is nothing but component input, and execution input is nothing but the initial request that you receive. Okay, so now you have two inputs. With the two inputs, you can manage your own operation. Okay, suppose you want to get a request ID and header information, you can go and get from execution input. Suppose if you want to get that modeled input, okay, then you from step input. Okay, and finally, and after then, what's the thing is, it will try to see here. It applies the function, which is a Java function apply. Apply automatically calls it prepare request and then process, and then prepare response. If there's any failure, then it calls it calls a recovery. Okay, and after that end execution, it resolves that output expressions also, and that output will be stored here, and it will be returned back to that. And finally, end of thing, it returns the context status, okay, as a success, so that it can traverse to the next node. And once it reaches the next node, it tries to get that plugin information once again corresponding to that node, and it tries to process in a similar way. Okay, I pass it here, and then we can continue on Thursday. Okay, so it's up to you, Yuri. That's all I have. Yeah.